Okay, in section, got a little offset there. In section number 2.1, problem number 73 says to use the alternative form of the derivative to find the derivative at x equal to c, if it exists at all. So, the alternative form of the derivative is the limit as x goes to c, and this is f prime at a value c, equals f of x minus f of c divided by x minus c. So our f of x in problem number 73 is x squared minus 5, and they want to know for what the derivative is when c is equal to 3. So this is the limit as x goes to 3 of, alright, well f of x is x squared minus 5, and it's going to be minus the quantity of, notice that I say the quantity of f of c, and f of c is equal to f of x except with c's there instead. So it's going to be, one thing that we can do is we can do the direct substitution there of 3 squared, well, I'll just put it in, 3 squared minus 5 divided by x minus 3. So this is going to be equal to the limit as x goes to 3 of x squared minus 5 minus 9 minus 5. Hey, I'm rewriting everything over and over and over again, right? I'm not just doing all the steps all in one step. I would rather burn a million trees than miss a step here, right? Do yourself a favor. Follow the same philosophy. Or pick up Smooth Draw 3, which is a freeware program, and do all your homework on that, and then just print it out later once you did it all correctly, right? So there's a environmental solution for you. So x goes to 3 of x squared minus 5. X squared minus 5. Minus 9 minus 5 is 4, so it's going to be minus 4 divided by x minus 3, which gives us limit as x goes to 3 of x squared minus 9 over x minus 3. This is a lot like the problems from problem number 1, right? Or section number 1. So x squared minus 9 is the difference of perfect squares. So we can find the limit as x goes to 3 of x minus 3 times x plus 3 divided by x minus 3. Removable discontinuity right there, right? So this is the limit as x goes to 3 of x plus 3, and there's nothing stopping us from using direct substitution on this, so this is equal to 6. And hopefully that's what we get in the back of the book. And it is, because I don't even need to check it, right? I just know. I know. Okay, so that's number 73. And we could probably do another one on the same video. So what was the next one? That was 79. Okay. So let's start it off. Problem number... one moment. Problem number 79. And we'll erase this. Okay, so problem number 79. Let's see. Get a pen. Alright. Problem number 79. It's the same type of thing, but instead we have a different function definition. So this is problem number 79. F of x equals to quantity of x plus 3 to a 2/3 at a value c equal to negative 3. So we have our limit definition as x goes to c, f of x minus f of c divided by x minus c, and our c in this case is negative 3. So we have f of x, which is x plus 3 to a 2/3 minus negative 3 plus 3, which is 0. So 0 to a 2/3, which is just 0. And then x minus a negative 3, which is x plus 3. Okie dokie. So this is equal to the 0 we can just rewrite. So this is equal to the limit as x goes to negative 3 of x plus 3 to a 2/3 over x plus 3. Now one thing that we notice here is that we have two common bases, x plus 3 and x plus 3. So if we have two common bases, we can do something with their exponents if they're being multiplied or divided by one another. So if they're being divided by one another, we can subtract. So we have the limit as x goes to negative 3 of x plus 3 to a 2/3 minus 1. 1 can be rewritten as 3 over 3, so it's 2/3 minus 3 over 3, which is equal to the limit as x goes to negative 3 of x plus 3 to a negative 1 over 3. Right? Right. So, this is equal to the limit as x goes to negative 3 of 1 over x plus 3 to a 1/3. Okay, so we can see that there is no factors in common between the numerator and the denominator. We have x plus 3 to a 1/3, and if we did direct substitution on this, we would get division by 0. This would tell us that there is likely a vertical asymptote at x equal to negative 3, and therefore the limit would not exist at x as x approaches negative 3. So if that is true, then the derivative does not exist at that point. Notice that this is within the realm of possibilities that is given in the directions. It says use the alternative form of the derivative to find the derivative at x equal to c if it exists, and it does not. So we do our simplifications and get to a point where we can recognize that the factors in the numerator do not cancel with any factors in the denominator, and it would tell us that the limit does not exist. Okay, so that is number 79.